So we talk about carbohydrates now. Carbohydrates are essentially sugars and disaccharides and polysaccharides. And over here on the left side, you see a structural formula of a substance called ribose, and you know immediately that the ribose is a sugar because it has the ending "ose" here. All the things that end in "ose" are sugar. The chemical formula for ribose is C5, H10, and O5. So there are 5 carbons, 10 hydrogens, and 5 oxygens in ribose. And like carbohydrates, you notice that essentially there are the ratio between hydrogens and oxygen in carbohydrates is 2:1. So there are usually twice as many hydrogens than there are oxygens in carbohydrates. Now, if you look at the chemical formula over here, and if you look at the structural formula of ribose down here, then you're probably going to realize I don't see the carbons. I mean, I see one carbon over here, but where are the others? Where are the other carbons? And there's one thing that you have to know, that the way that the formula is written over here is a short form. It's a simplified form, because every corner over here that you have is a carbon. Because we're talking about organic chemistry, and carbon is so important that essentially they don't even talk about it. Okay, if something is so important, it's kind of weird, but it reminds me a little bit of a story. My wife used to make a cake several years ago, and she didn't make it once, she made it 5 times, because she did not succeed 5 times. It never worked. It always got stuck in the cake form, and it was a disaster. You couldn't eat it. And then basically she got the recipe from her mom, and she really kind of stuck to the recipe, because her mom's cake always worked, and it was a great recipe. But after 5 tries, and it didn't work, so essentially she called her mom. I remember this telephone call quite well, until we discovered that essentially on the recipe, she did not include flour. You have to also, if you make cake, you have to include flour. And her mom then said, well, it's kind of clear that you have to include flour, because it's obvious, you always have to include flour, but it was not on the recipe. And it's a little bit like this over here. It's kind of obvious that you have to have carbons in organic chemistry, but they just don't tell you. Okay, so then later on she added flour, and then we had a great cake. Yeah, so just it was a simplified recipe. That's what I wanted to say. So over here we have a carbon over here, we have a carbon over here, we have a carbon over here, we have a carbon over here. So I have my 1, 2, 3, 4, 5 carbons. So I'm happy over here. This is my 5 carbons. I need my 10 hydrogens, and I see 1, 2, 3, 4, 5, 6. Now where are the others? The same thing. Well, they didn't write. It's a hydrogen is over here, a hydrogen is over here, going away from the carbon, and over here as well. So and now you have your 10 hydrogens. Because what else should it be? Because if it were something else than a hydrogen, they would have written it down. And the 5 oxygens, of course. And we have 1, 2, 3, 4, and 5. The oxygens, that's kind of fine, okay? And that's basically ribose. And the ribose is an example of a so-called a pentose sugar. How do you spell sugar? Okay, pentose, yeah, kind of obvious. It's a pentose, because ose also implies it's a sugar. And pentose, you think, because it looks like a pentagon with 5 corners, but that's not the reason. The pent refers to the number 5, because it's a 5 carbon sugar. So it's a 5 carbon sugar. And why do you have to know this? Because ribose is really super important for RNA. It's the sugar in RNA. It's a sugar in RNA, in ribonucleic acid. And in DNA, you have a so-called deoxyribose. In DNA, and deoxy means that there is 1 oxygen less. And which one? In DNA, I'm just going to tell you that this oxygen over here does not exist. It's directly connected to the H. Okay, so just in DNA, the chemical formula is C5H10O4. Okay, so but that's basically just side information right now. I just wanted to make it clear because some people want to know, why do I have to know this? And I'm telling you, well, you gotta know this because when you talk about DNA and RNA, it's really kind of important. So now that's basically was basically ribose. Now let's have a look at the next one, and this one is glucose. Okay, and you also see that it has a ring structure over here, and the chemical formula for glucose is C6H12O6. Glucose is a hexose sugar because it contains, it's a 6-carbon sugar. And I think I do not have to mention it, that essentially over here we have the same story. We have over here a hydrogen, we have over here a hydrogen, over here we have a hydrogen, over here and over here as well, because carbon always has 4 bonds. And where are the carbons? There's a carbon over here, there's a carbon over here, over here, over here, and over here. So let's count the carbons. 1, 2, 3, 4, 5, 6. Actually, I should have counted clockwise because that's the system that you use in chemistry. Doesn't matter. Hydrogens, it should be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens and 6 oxygens. 1, 2, 3, 4, 5, and 6 over here. And that is basically, that's glucose. That's our main energy source. So when we eat starch, starch is broken down into glucose, and this is basically the stuff that's our fuel. And that's basically why you have to know that. Now, the point is the following. There are now basically 2 forms of glucose, and I'm going to talk about this later as well. The OH group can either stick out here down, or it can actually also point upwards and be flipped around. So there are 2 forms of glucose, which I'm going to talk about when I talk about cellulose and when I talk about starch. But for right now, that's basically all that you have to know. If you want to draw this, and then it's actually quite simple to draw. Essentially, what you do is you start out with the oxygen over here, and then you simply draw something like this. And over here, you draw a line, 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 and then you remember the following: down, it points downwards, down, down, up, down, up, down, down, up, down, up. And these are the OH groups. So over here, I draw the OH like this. OH, down, down, up, down. It doesn't matter into which direction I draw the OH. So I can also draw it like this, down. And here at the top, I don't have an OH group. I have a CH2 and OH. I can either write it directly next to it, or I just write it like this. Same thing. And everything else are hydrogens. Just fill it in with hydrogens. So that's basically why I told you you should always go clockwise, because it's down, down, up thing. Yeah, it goes, when you go clockwise. You know, that's basically how you draw a glucose molecule. And over here, not drawn, of course, are the carbons for simplicity purposes. But don't forget to count them when you want to double check that you have all the carbons. Some people like to forget the CH2OH group up here, and they simply fill in an OH group, and then they have essentially 1 carbon too little. And that's, of course, not going to work. So that's basically an introduction into monomers. Monosaccharides, and these monosaccharides basically are the building blocks for disaccharides and polysaccharides, which I'm going to talk about in a different video.